Assalamu alaikum. Hello, everyone. We continue with topic 6. Before we start from where we left off last time, I would like very quickly to mention something. You remember last time when we plot BCA1 versus BCA2 differentiated by the number of cylinders? So we did plot that in the normalized version of the data, because actually we normalized it in place. Okay, we didn't create a new data frame. So that's why we were seeing here the normalized values. But actually, these normalized values, maybe the physical meaning is not clear to us, because these have physical meanings here. The number of cylinders, 3, 4, 5, 6. This is what we know, okay? So then with that, maybe it wasn't so clear, like what were the original numbers. So we want to see the original numbers in the figure. You can always actually, when you do normalization, you can keep the original data frame. You normalize and you create a new version of the data frame, and that a normalized version. Then you work in that one. You can compute the PCAs and do whatever. Then if you want to plot something and visualize them, you always can go back to the original column. Okay, you can always use that. Like you can copy it to the because now we're just using it for differentiating the colors. So we can copy it to the new normalized data frame and use it to differentiate the relationship between BCA1 and BCA2, and then we can drop it after that. Okay, that's something I wanted to mention very quickly. Now let's start from where we left off last time. So we will start with the cross table. Okay, so this is the cross table here. So here we want to plot a cross table showing the total number of customers for education and job columns. So we have two columns, okay? Then we can pass them to cross table function, okay? So the pandas built-in cross table function. So we pass, this will be taken as the different categories. For this will define the number of rows, and the different categories for this, the number of categories for this will define the number of columns, okay? So when we run this is what we get, okay? So here, okay, these are all the different jobs, okay? And these are all the different education levels, okay? Or you can all categories for this variable, and these are all the categories for that variable, the categorical variable. So now this element represents what, for example? This is actually the total number of records where the job is admin and the education level is primary education level. So these are the counts, okay? That's for the cross table. We come to pivot table. Pivot table allows you to actually build rows based on more than one attribute. So here, pivot table displaying, this is what we want to build. Pivot table displaying total subscribers for marital, job, and education columns, okay? So we can also specify what the values represent what. Here, the values are the count, okay? So since here the values, we want them to represent the number of subscribers, the subscribed column is not a numerical column. The values are either yes or no. Then the first thing we do, we create a numerical version of it where we actually replace yes with 1 and no with 0, okay? Then we call the function pivot table. The values are the subscribed numeric, the column we just built. This will, the values will be based on this. And then the index or the rows, now here you see we are defining more than one row, okay? So the rows are what? Are the marital status and the job, okay? So then the total number of rows will be the total number of different categories we have in this one times the total number of different categories we have in this one. The total number of categories of this times the total number of categories for this one, or unique values. And the columns will be defined by the education level. So there are 4 education levels, okay? And then we choose aggregation function for those values, okay? So the aggregation function here is sum, okay? So we will sum, like for any intersection, like for a given marital status and job, okay? And education level, we will sum the elements of subscribed numeric for those records that satisfy this contingent, or they are in the intersection of all of these. There are different choices for this one. For example, you can compute the average. Okay, it depends on your use case or application. For example, if you're looking, for example, the average sales per day or per month or something, then you may need to call the average. Okay, you can always call the help function for this. You see the different choices for the aggregation function. Okay, let's display the table. Okay, here's the table. Okay, so as you can see here, let's look at this. Okay, so now the marital status, it's alphabetically ordered: divorced, then married, then single. Okay, now this first row here, divorced, for the marital status with admin job. Okay, so now here is like, what's this exactly? So this is the number of subscribers, the total number of subscribers, because when we sum this, these are zeros or ones. Okay, the values of this column are zeros and ones. So then when we sum, we get the total number of subscribers, because it will contribute only the number of subscribers will contribute to the sum, because for the non-subscribers the value is zero. So this represents the total subscribers, where the total subscribers from which and which choice for the marital job and education. So this is the total number of subscribers where the marital status is divorced, the job is admin, and the education level is primary. So there are no subscribers in this intersection. Okay. Now there are, like, for when the marital status is divorced, the job is admin and the education level is secondary. There are 11 of those, and so on. Now, when you see none here, that means there was no record there. Okay, so here there were records where the marital status is divorced, the job is admin, and the education level is primary. There were like records with that, but none of them has subscribed. That's why it's zero here. The total is zero because we're summing zeros, so it's zero. But here there was no record with that. So there was no record where the marital status is divorced, the job is blue color, and the education level is tertiary. There was no records there. That's why it's empty. It's none. Okay. Okay. So I don't know what's this here when we display again. Okay. So sorry. Okay. This is actually back to the data frame. Okay. We just dropped that. This was just created. As I said, the thing I mentioned about number cylinders for in the top. So this was created just to do this differentiation, and then we dropped it. Okay. Okay. So now, okay, box plus for each numerical and categorical column, and differentiated using subscribed column. We have done these things in the past. Okay. So here, what are we doing? So all the categorical columns except the subscribed, we remove it. And here also we are selecting all the, so here we are selecting all the categorical ones, and here we are selecting all the numerical ones. And then we're creating a number of subplots that's equal to the length of the, so it's actually, there will be 2D, there will be a number of rows and number of columns. A number of rows is defined by the number of categorical columns, and the number of columns is defined by the number of numerical columns. So there will be this much, or this grid of subplots, and then we are iterating over all numerical columns. And since this is a list, we pass it to enumerate to add index, so we can iterate over those elements. And we're doing the same for the categorical columns. And then for every axis, that's now defined by R and S, where R and C, sorry, where R and C, they iterate over the different numerical and categorical columns. And we are plotting a box plot here. Box plot for what? X is what? X is the categorical column. Okay. Of course, it has to be that, right? Because we're plotting box plot for a numerical column that's differentiated by the different choices or categories of a categorical column. So X has to be the categorical column. Y is the numerical column. So for every numerical column we have, we will plot the statistics of that differentiated by the different categories or unique values or classes of the categorical column. And we differentiate them by subscribed. So if this is not there, after adding this, every subscribed is yes or no. So every bar or every like box plot would be replaced by 2 because we are differentiating. So we're plotting the statistics of the ones who have subscribed separate from the ones who haven't subscribed. Okay. So here we're defining the data frame and the axis, and that's it. So here the labels, and we rotate them so they do not overlap. And this is what we get here. Okay, this is the number of boxes. So the number of columns is defined by the number of numerical of the numerical attributes or columns. So that's why there are 2, because we have 2 numerical columns, right? And that's it. Okay. So these numerical columns are the age and the balance. Okay. 2, 3, 4, 5, 6. So there are 6 categorical columns. And for every one, as I said, we plot the box plot of this. For example, this is one of the numerical columns. So we plot the box plot for age differentiated by different choices for job. Okay. And for every job, we are plotting 2 box plots. Okay. Box plot for the age attribute for this given specific job for the ones who have subscribed from this job. Okay. And the second one is for the ones who haven't subscribed. Okay. So that's it. So now if we want to answer this, you can infer many things here by looking into this. Okay. We have been doing that. Okay. So let's maybe answer this question here. Which age group subscribed the most? Okay. So where you get this information from? Actually, you get it from the histoplot here, right? If you look at here, this one. Okay. So this is the histogram. These are the bins of the different ages. We can clearly see like the ones who have subscribed the most are the ones from like 30 something to almost 40. Okay. So the blue is for the subscribers. Okay. But they also the ones who haven't, like, it seems like most of the data, like it's the mode of the data. So there are more here. Okay. There are more have subscribed and more haven't subscribed compared to any other age. Okay. So it's just like most of the data is from there. Okay. So which combination of job education has the most customers? Job education, this we can take it from the table, right? So we have the table. Okay. So then we can retrieve the index as well as the max from the table. Okay. From the cross table. So this is the this is the printout of the first one, the ID max. So actually IDX max. So this is a series, okay, where the labels are the so let's look at this here. Okay, the first one here, the IDX max. This is a series where the labels are the columns in the table, in the cross table, and the values are the rows. Okay, for every job here, for every education level. It's not this one, it's this one here. For yeah, this will be the labels or the indices. Okay, and the jobs will be the in fact the max, only the max. Okay, we're getting only the max for each one. For primary, for example, what was the max? The max is blue color. So then the first one, primary, the max, which is the value, will be blue color. Okay, that's okay. We are retrieving the indices here. Okay, so these are the indices. So here we have retrieved the indices. Okay, for primary, the max, the job with the max count is blue color, and so on for the others. Now that's the IDX max. The max itself is the total for every column. So the return of this, when we call cross table dot max, the return of this is a series where the indices or the labels are the columns or the attributes, and the values are the counts. Okay, so this is the count for the primary. The highest value was 369. Now we have the indices and we have the counts. Okay, then we just concatenate them column wise. Okay, x is equal to 1. So we concatenate them horizontally. Okay, and this is what we get. So for primary, the max is the job that has the highest count is blue color, and it has occurred this much. There are this much of number of records with this job for primary education level, and so on. Okay. So yeah, we did that. So now, which combination of marital, job, and education subscribed the most? Okay, it's the same thing, but we just take it from the pivot table. Okay, it's the same idea. So it's just like it will become tuple here because there were two. It was intersection of two attributes. So then the value here will be tuple. So the columns will be the labels. Okay, and these are the values of the IDX max. Okay, so this is like the index in the original table. Okay, so for primary, the combination that has the highest count is the combination of married and retired, because married and retired define the index here. Okay, the index is defined by this. Okay, like for example here, married, retired, here they have 12. Okay, that's the maximum. Okay, so then the index will be a tuple, will be a combination of these two. That's the only difference compared to the cross table. Okay, so this is a tuple, and this is the corresponding value. The rest is the same as we explained in the previous cell. We come to the last cell here. The bank is planning to have a new scheme for students. Which age group students should they consider the mostly? Okay, so we are selecting only the student ones. Okay, and then we plot the final plot. I will explain why final plot. So then Y will be the age, and X will be the job. This is the categorical one, and we are plotting the statistics of this differentiated by this. In fact, this has now yeah, X is equal to job, and we are actually plotting that for only the selected segment. For the selected segment, there's no other job. It's all of them are students. Okay, but because we want to use the hue, we have to consume X and Y first. We have to use X and Y in order to pass the hue. Okay, so then that's it. Then actually let me, before explain the rest, let me plot it here. This is it here. Okay, so it's differentiated by the job, but in fact there is only one job here, student. But we are plotting the statistics of the ones who subscribe different from the ones who hasn't subscribed. Okay, why we plot the final plot? Why not box plot? Because actually at any given level, we can see like the width depends on the number of subscribers. So here we can see like most of the subscribers, okay, or the highest number of subscribers, is in this age segment, like something between maybe 25 and maybe say 25 to 28 maybe. Okay, but the same here, the ones who haven't subscribed the most, maybe they are in the same level. So this also gives you indication like that most of your data is from there actually. Okay, maybe the conclusion that you target this segment is not really the most right conclusion. Is just like because most of your data is there, so you have most of subscribers as well as non-subscribers are from there. Okay, but yeah, if you see like the most is here, then between Q1 and Q3, then you can actually consider this, like, okay, take the retrieve Q1 and Q3, and then you consider the segment between Q1 and Q3. Okay, this is what we which here they are between. Okay, so they're between 22 and 27. Okay, so you can target that one. But again, as I said, it seems like most of the like ages or this is the segment where you have more data than any other segment. Okay, maybe that conclusion you target this is not, because if you look into only this, then yeah, I agree. So most of the subscribers are here. But if you look also here, most of the ones who haven't subscribed are also from the same segment. Okay, it seems like most of the data is just from there. Anyways, with that, we come to the end of this topic. Thanks for watching. Assalamu alaikum.